Welcome back class 10th student. Now we are going to discuss the last session of work, power and energy. In the previous section we have covered the potential energy, right? And we have discussed about work energy theorem. And now in the last session one derivation related to the conservation of energy and one example of how the energy convert from one form of energy into the another form of energy. Only two things are left. So now starting from definition of conservation of energy. You all know from the junior classes, you all knows very well, conservation of energy means energy neither be created nor be destroyed. We can transfer only one form of energy into the another form of energy. In class 6, 7th, 8th, you all knows very well about this conservation of energy. For example, our body energy convert into a different form like sound energy and the heat energy. When we are running on a particular path, the energy convert into the kinetic energy. तो एक साइकिल है, you know very well कि उसमें conversion होता रहता है, but we cannot create or destroy the total energy. So with the help of one example, that is a freely falling body, we are going to show that mechanical energy is always conserved, that is kinetic energy plus potential energy. And to prove this phenomena that the kinetic energy and the sum of kinetic and potential energy is equals to mechanical energy at each and every point during a freely fall of any body. सो बस ये कन्वर्जन दिखाई देगा, कहीं काइनेटिक इंक्रीज हो जाएगी, कहीं पोटेंशियल इंक्रीज हो जाएगा, बट ओवरऑल जब हम लोग डेरिवेशन करेंगे तो यू विल रियलाइज दैट द मैकेनिकल एनर्जी इज कांस्टेंट एट ईच एंड एवरी पॉइंट. सो लेट अस कंसीडर फॉर द प्रूफ, सपोज a total height is b, suppose h, and the body will placed at the height b. We are check at this point of B about kinetic energy and then potential energy, right? हम इस तरह से स्टडी करेंगे कि B पॉइंट पर चेक करेंगे किसी पर्टिकुलर बॉडी की काइनेटिक एनर्जी एंड पोटेंशियल एनर्जी एंड देन टोटल एनर्जी, और यू कैन से द मैकेनिकल एनर्जी. आफ्टर दैट वी freely fall this body and ball will reach at point suppose C. Then again we will check kinetic energy and the potential energy at point C, and finally we will check kinetic energy, potential energy at point A. So you can change the point also, because of that it is much better कि आपको अच्छा सा लगे A B C, A B and C, only for your comfortability we are changing this A B and C. Now how to start from at point A. इन शॉर्ट मैं आपको बता दूं, हम लोग क्या चेक कर रहे हैं, पॉइंट ए पर टोटल एनर्जी, पॉइंट बी पर टोटल एनर्जी, पॉइंट सी पर टोटल एनर्जी, और इन तीनों ही केस में हमारे पास टोटल एनर्जी क्या आएगी, कांस्टेंट. वी कैन से कंजर्वेशन ऑफ एनर्जी इज़ वेरीफाइड, और यू कैन से एनर्जी इज़ ऑलवेज कंजर्व्ड. तो एट पॉइंट ए, सबसे पहले पॉइंट ए पर बात करें हम आपके लिए. व्हेन ए बॉडी प्लेस्ड एट पर्टिकुलर पॉइंट ए, you can say the initial velocity is 0, right? So that kinetic energy is half m v square. Initial velocity u आपके पास 0 हो गया, that kinetic energy is 0 at point A. And what about the potential energy at this point? If you see the potential energy, that is mgh, where m is the mass of the body, h is the total height where we place the body, h, and g is a gravity. Now you can see total energy is kinetic energy, or you can say mechanical energy plus potential energy the sum is equal to mgh. Now we are going to calculate again kinetic energy and potential energy at point B. So at point B, let the velocity at point B be v, and the height covered by the body be x. ये हमने कवर करी कितना, x. Now from equation of motion, पहले कोई रिलेशन हम निकालेंगे. From equation of motion, v square is equals to u square plus 2gx at point B. Final velocity is v square, initially 0, that is equal to 2gx. Now you can say v square is 2gx. After that, calculate the kinetic energy. Kinetic energy is half mv square. If you put the value of v square, that is 2gx, to cancel with this, and the part is mgx. And now potential energy at point B पर बात कर रहे हैं. mg at point B पर आपके पास रह जाता है h minus x, because x distance, x height body शिफ्ट हो चुकी है डाउनवर्ड, तो रेस्ट ऑफ द हाइट हमारे पास रह जाती है h minus x. Now the potential energy is mgh minus mgx. Then calculate the total energy. Total energy means kinetic energy plus potential energy. Now kinetic energy is mgx and potential energy is mgh minus mgx. mgx cancel with this part is equal to mgh. This is called total energy. Alright dear, and now come at point C. Now at point C, again we are calculating that let the final velocity during when the ball impact on earth, then the final velocity be, मैंने इसको बोला v dash. So again apply v dash square is equals to u square plus the total height cover is h, the 2gh at point C. So v dash square is initially 0, 2gh, now that is equal to 2gh. And calculate kinetic energy at point C, that is half m v dash square v dash square, and now put the value of v dash square, that is 2gh, cancel with this, and this section is equal to mgh. And potential energy, potential energy is mg, h is 0, because of that at the bottom height is 0, so the total potential energy is equals to 0. Now calculate total energy, that is again kinetic energy plus potential energy. Now in this time potential energy is 0 and kinetic energy is mgh, hence we can say energy is conserved, because of that at each and every point the total energy is equal to mgh. That the most important section of this, we are proving that कि किसी भी पॉइंट पर आप कैलकुलेट करें पोटेंशियल एनर्जी एंड काइनेटिक एनर्जी का सम हमेशा कंजर्व रहता है. सो दैट्स only a single derivation in your book. इस तरह से आता है ये कई बार. And the second example again given in your book is example of simple pendulum to explain you that how to shift kinetic energy to the potential energy and potential energy into the kinetic energy. So in a simple pendulum motion, we all know very well, suppose motion is starting from this point A. So on that time we are holding this bob, that is called bob. This one is string, this one is a rigid support. So कभी आप कहें एक बॉब तो छोटा लग रहा है, एक बड़ा लग रहा है. भाई आई एम नॉट ए ड्राइंग टीचर, बट ठीक है कर देते हैं थोड़ा सा. So the at point A, when you hold the bob in your fingers, on that time we can say the kinetic energy is 0 and it is a maximum displacement. So we can say potential energy is maximum. When you release the bob from the point A and body will move towards B, you will see velocity increases and the distance decreases. At point B, the total displacement is 0. We can say the potential energy is 0. On that time velocity is maximum, so we can say kinetic energy is maximum, or you can say the total potential energy convert into the kinetic energy. Again body will move towards the point C. Slowly velocity decreases and the distance increases. At particular point, ball due to the gravity, so that ball will stop at point C. On this time kinetic energy 0 and again potential energy is maximum. And during the path of B to C, we can say kinetic energy convert into potential energy slowly, and after that at point C, the total kinetic energy convert into potential energy. I hope you will understand easily. One graph is given in your book, so understand of this conversion of kinetic to potential and potential to kinetic. To learn this graph also, okay, what is the flow of the graph, you will see यहाँ लिखा है height, राइट बेटा, और इस तरह से दो लाइन ड्रॉ की गई हैं. One line is showing that if your height is slowly increases, then the potential energy is increases. That line shows that the potential energy is increases, and जैसे जैसे height increase हो रही है वैसे वैसे potential kinetic energy is decreases. Potential energy is maximum, then kinetic energy is 0, and then यहाँ पर अगर मैं आता हूँ, then height is 0, so we can say on that time the kinetic energy is maximum. So one graph is given in your book also. I will revise you from the book, rotate the pages. तभी आप लोग सेटिस्फाइड होते हैं कि हाँ बुक से हमारा ये पोर्शन भी कवर हो गया है. तो इससे पहले वाला पोर्शन वी हैव ऑलरेडी डिस्कस्ड. ये एनर्जी चार्ट लास्ट वीडियो में हमने डिस्कस किया था. आपसे कहा था इनके दो एग्जाम्पल ज़रूर लर्न कर लीजिएगा. लॉ ऑफ कंजर्वेशन ऑफ एनर्जी, एंड दैट इज एग्जाम्पल इज गिवन ऑफ फॉर अ बॉल फॉलिंग फ्रीली, the derivation, and after that given a graph from the very right side, and that is also shows a one diagram of mechanical energy conversion. On that particular height the potential energy, and then will you release the ball, potential energy convert into the kinetic energy. The same concept used in hydroelectricity. You all know very well कि हम वाटर को एक पर्टिकुलर हाइट पर होल्ड कर लेते हैं. You all know very well एक डैम बनाया जाता है. जो डैम होता है वो क्या होता है, रिजर्वायर होता है. वाटर रिजर्वायर फिल कर देते हैं ऑन दिस साइड, वाटर रिजर्वायर, जिसको हम बड़ी वॉल खड़ी करते हैं, दैट इज़ कॉल्ड द डैम. उसके बाद हम क्या करते हैं, यहाँ पर प्लेट्स होती हैं बेटा, उन प्लेट्स को हम खोल देते हैं, नंबर ऑफ़ प्लेट्स, जिससे वाटर एक हाइट से जब गिरता है और इस तरह से स्लोप बना होता है लाइक दिस, वाटर जब इस तरह से आता है, देन पोटेंशियल एनर्जी इज़ टोटली कन्वर्ट इनटू द काइनेटिक एनर्जी. और बेटा यहाँ लगा होता है टरबाइन. द टरबाइन will rotate, right? बहुत अच्छी ड्राइंग नहीं है मेरी, पर फिर भी ट्राई करता हूँ. दैट इज़ अ टर्बाइन. ये वाटर का जो फ्लो होता है इस टर्बाइन पर आकर के गिरता है, टर्बाइन रोटेट होता है और जिससे इलेक्ट्रिसिटी जनरेट होती है. दैट इज़ द वेरी प्योर कॉन्सेप्ट ऑफ कंजर्वेशन ऑफ एनर्जी, where potential energy convert into the kinetic energy. Very fine example in your real life practically. So that is part of this, and after that memory plus तो आप लोग अपने आप पढ़ ही लेते हैं. Conservation of energy in case of the pendulum I have explained already, and now you will see that the chapter is finished. So I hope you will understand this especially chapter work, power and energy, and start the numerical portion. Start the numerical problem. First solve the example. In the next session we will take your start the numerical problem from examples, and try the question from your exercise book, and the next time we will discuss about the numerical, and then start a very fine chapter that is called a simple pendulum. Thank you very much. Take care.